There you go. Right. Okay, we got the recording going. So I want to give everybody a welcome to our presentation today. You're very welcome to be joining us here. We've got speaker lined up for you. This is Coaching Agile Journeys. It's number 14 for us that we've been doing. Isaac Garcia, I'm one of the co-hosts of this. Lori is also here. Heidi and Jeff might pop in now and then, but we've got the primary co-hosting responsibilities today. So if you're first time joining us here, we are a group of Agilists who are on a journey, and that's where the name comes from. And so we recognize that it's more fun to go on a journey with people instead of going alone. So we're a group that's committed to living out our Agile journey together and to live it out to the fullest. So at coachingagiljourneys.com is where you can find us. That's where you'll see information about upcoming talks and as well as previous talks. If there's something that you hear today that you'll remember and go, ooh, I want to hear what that was again. In the future, we'll get the recording posted there on coachingagiljourneys.com in a blog post. So you can come back and review it. We should also have the slides there once we're done. So what we'll do today is we're going to get into our topic. Rick's going to be here in just a second. And so before he does, just a couple of notes about how Zoom works. So instead of doing a webinar style where it's us talking and everyone just listening, we wanted to make sure that the question and answer time was back and forth and you could actually communicate. So what that means is I'm going to start us off by muting everybody, but inside the Zoom interface, you're very welcome to unmute yourself. You can turn on or turn off your camera, up to you. If you have a question for Rick, you can shoot it there. If you're not comfortable saying it, you're more than welcome to put it in the chat. Both Lori and I will be monitoring the chat as we go up to the end of the talk, and then we will come back on and engage with Rick for the question and answers. And if nobody else has a question, if we have some, we might lead the discussion that way. So we're going to go through the content now, and I'll introduce Rick. And Rick, it is all yours. Thanks so much for being with us today.
Okay, thanks. Let me see about sharing my slides here. And
Did the button disappear?
yeah, well,
I might have broken something.
Yeah, I want to. I think I need to set this up properly here. We did all right with this when we were practicing.
That's always the way it goes.
So let me see what I can do with this.
I see something coming up. There we go. We've got you.
All right, now let me see if I can do it. Are you seeing it as a slideshow now?
No, I think we're seeing the presenter view.
All right.
Classic dual view thing. That's
all right. We'll just try it like this. How's that?
Sounds good.
Okay, so what I'm going to talk about is principles for constructing quality software and what I consider that to be a fundamental approach to that. And I can't do this without some of my favorite quotes, so you'll have to bear with me on this. So this is from Phil Crosby, and I studied quality management at Crosby Quality College back in the 80s. So quality is free. It's not a gift, but it's free. What costs money are the unquality things, the actions that involve not doing jobs right the first time. Not grammatical, but true. And then there's a classic, Harold F. Dodge, quoted by Deming, you can't inspect quality into a product. And my personal favorite, from Steve McConnell, Code Complete 2, trying to improve software quality by increasing the amount of testing is like trying to lose weight by weighing yourself more often. I've tried that, didn't work. So what do I mean by the basics? And first of all, I want to define quality. And I'm going to go back to Crosby again here. Quality is meeting the requirements, and it's not exceeding the customer's expectations, which is something that I saw in a different quality management program that I frankly didn't think very much of. Why is that? Well, in the case of software development, it's particularly dangerous to take that approach because that sort of opens the door to feature creep or gold plating, whichever you want to call it. Quality improvement normally requires changing the process, and that means that fixing problems earlier is more effective and less costly than fixing them later. And to do that, you find the causes of defects and fix the causes in your process. If you fix defects without identifying and fixing the causes, that doesn't really improve your product quality. So I would say that setting higher standards helps drive better development practices. So there are two ways to get started with an approach like this. If you look at classical quality management, I'm sorry, am I getting a question here?
Yeah, if you're moving on your slide presentation, we're not seeing that. So,
oh, okay. Hang on a second. Let me see if I can fix this basic. Let's see. Are you seeing the slideshow now?
Nope.
All right. All right. Hang on a second. Let me see if I can fix that in a different way. Let me go to the slides themselves. And
there you go. You got it.
Well, I didn't do anything different.
Okay.
Is it just a delay?
Oh yeah, you just moved your navigation on the left.
Yeah.
Yeah, we're on the quality is free. It's not a gift slide.
Yeah. Hang on, just let me stop sharing this for a minute here and see if I can do this differently.
Yeah, no problem.
And
while you're doing that, I'll remind everybody, if you have a question and you don't have a moment to break in, I was actually so glad Lori broke in. I was waiting for just a second to jump in to say that about the slides. If you have a question but you don't want to interrupt the flow, just throw it in the chat window, and that way we can keep it and we'll collect all those for the end. So just
all right, let me try doing this differently here and see if I can share. Okay, let's try this. All right, you're seeing it as more of a slideshow now, I hope?
Yes, it's your first slide.
Okay.
Yep.
Yeah. All right.
There we go. Yes.
All right.
Now we're with you.
All right, so let's get back to where I was here. So I would say there are two ways to get started. If you look at classical quality management, it sort of tells you to identify and fix process defects that might, in fact, be unique to the way you do things or your organization. I'm not sure that's a good way to do this, and I think that Richard Hamming is the source of this quote. How do I obey Newton's rule? He said, if I've seen further than others, it's because I've stood on the shoulders of giants. These days, we stand on each other's feet. I think that we should stand on the shoulders of giants, and in fact, you can actually see further if you just stand on the shoulders of ordinary-sized people as well. So I would say if we want to profit from the work of pioneers in the field of software quality, we owe it to ourselves and to them to stand on their shoulders and not start from a clean sheet of paper, if you will. So here are your sort of standard phases of software development, with apologies to Agile approaches, but nevertheless, if you look at these, most people will concede that a good source of errors, or a good way to introduce errors in the requirements definition phase, that's not what I'm talking about today. I'm talking about construction. I'm talking about the part where you're building software. So that's my focus. And what's wrong with software construction? Historically, I would say it's a write-only exercise. If it doesn't break, nobody else reads it. I've had people disagree with me on this, but I've been at this for almost 47 years, and I think that it's largely true. That if you write software that works, pretty much, unless you coerce it through your process, nobody else is going to read it. Also, you have standards that don't exist or that are made up on the spot, that are ad hoc. Testing is treated as a separate exercise. And of course, you've got rework or patches to fix defects, otherwise known as bugs. There, aren't they cute? Features tend to take precedence over quality. That's the reason why I don't think that you should try to exceed your customers' expectations. And the definition of quality itself isn't rigorous enough. So standards and best practices aren't followed because they're not stated as requirements. Well, what's missing in software construction? If we built buildings this way, they might not stand up, or maybe we might not. But buildings aren't built this way. So here I just want to diverge a little bit because I take some of this inspiration from one of my brothers who's an architect. And I like to say that he had the last laugh on his professors who said that he would never make much of an architect because he wasn't much of a designer. Well, today he is arguably Connecticut's leading expert on the building and fire safety codes, and he consults with other architects and with contractors on how to build buildings properly. So this is a list, which I'm not going to go through, of typical building code requirements. If you're curious, this comes from the New York State Building Code, which you can find online for free and read. That's what my brother said to me when I asked him for a copy of the Connecticut Building Code that he and my other brother actually published at one point, to thump on the podium when I spoke on the subject. He laughed at me and said, just look at it online. So what's missing is a building code for software because there's a lack of external standards. Organizations create their own standards. There's no penalty for inadequate standards, and best practices are the first thing to go under cost and schedule pressure. So where do building codes come from? They don't come from a blank sheet of paper. There's a starting point. The International Code Council, local authorities then vet that, and they use independent standards organizations. And here is the building code of the New York State. I won't read the details of where they get it from, but they get it from various standards organizations. So here's a concrete example. I call it that because how do we send engineers into a warehouse with a tub of concrete? Is that how we decide how to build concrete buildings? And the simple answer is no. We use the standards from the American Concrete Institute with a few adaptations and changes. It amounts to just a few sentences, actually, in the New York State Building Code. So how do we apply this to software? We can start by not inventing our own standards. We can identify industry best practices. We can enforce them in a couple of different ways. One of them is at the requirements phase, and the other is in setting rules for how we develop software, and that's how we make sure that our software doesn't fall down. So how do we improve development practices? One way is uniform coding standards, and you can find references and tools and best practices for this sort of thing. Another is automated unit testing. Automated unit testing has a lot of benefits, and I've outlined some here, but I'll talk about it in more detail. But it affects your design for test and different tools. And what I would suggest is an enterprise approach that you can take using these tools. Another is root cause analysis and classification. Now here I have sort of a bone to pick with the CMMI Institute, who in their current standards for CMMI puts root cause analysis at level 5, whereas I think that root cause analysis is sort of a basic practice that you need to do at all levels if you want to do continuous improvement. And code reuse. And code reuse, it depends a lot on where you get it from. Reliable sources are important. Capers-Jones says that code reuse can have the either best or worst possible return on investment depending on the quality of the software that you're reusing. So, uniform coding standards. I'm most familiar myself with the Microsoft.NET framework. The second popular framework is Java. And in both of those cases, there are places you can get references for design guidelines and best practices. You can get tools and techniques to use. Static code analysis. There are various tools that you can use and you should use. And the other is code review. And I say with audit because in the environment in which I work, sometimes you'll find that people claim to do code reviews and they either don't know how to do them or they only do them on paper. And if you're going to do them, you need to actually do them if you want to get the benefit from it. So static analysis for the .NET environment. Initially, it was Microsoft FX Cop, which was a free tool, but now there is an equivalent version in Visual Studio, the development environment, and FX Cop has been kind of deprecated. And there's actually another iteration that's coming that I was learning about at a conference I was at last week. But the idea is to analyze the code. In this case, it's language independent for that environment. It's applied to compiled code, and it lets you apply best practices that are known for that environment. Code review. One of the benefits for code review is, I think, is that the code is looked at by the developer, because you don't want to be embarrassed when you show your code to other people, and that can uncover defects and inspire changes right at the start. Also, when other programmers review code, it sort of gets rid of my statement about write-only exercise, because this is the best way to share ideas and improve techniques, and sometimes you discover better techniques when you look at other people's code, and sometimes you uncover defects or poor techniques in your own code. So that lets you determine and fix the causes of defects. The customer audit idea is to provide assurance that it's actually being done. Automated unit testing. So this is a very important tool, I believe. It has an impact on the design. If you know that you're going to have to write automated unit tests, you actually write your code differently. You don't drill down 4 or 5 layers before you do any work. You try to make things more compact and follow more solid principles and so on. It affects the design, and the, I used to call a more extreme version, but I'm not so sure that it's really extreme anymore, is test-driven development, where you write the test first. One of the benefits that I see from that approach is that it prevents you from throwing in extra features for just a couple lines of code, because when you've met the tests, then you know you're done and you go on to do something else. As far as tools and techniques, well, there are different ones for .NET and Java. There were actually tools. The first unit testing was actually developed for Smalltalk. It was called SUnit in 1994. JUnit was based on it in 1999, and NUnit and its descendants for .NET came after that. But they all follow the same kind of pattern, and sometimes they're referred to collectively as XUnit, although there is actually a test framework called XUnit. Now, the enterprise impact that I see from this is, first of all, if all the developers are using it, you have a uniformity. And the other thing is that, and in some ways I've seen this as sort of a pipe dream of mine, but ideally you'd like your test organization to be fluent enough in the use of this sort of tool, so that instead of coming up with a complicated scenario that describes where a defect happens, that they could write a failing test and give it back to the developer. Sort of saves a lot of communication. Okay, so root cause analysis. I've already said why I think that this is not something that should be confined to CMMI 5, but the way it basically works is that you find the cause, and there are different ways of approaching that. There's the Toyota original method of 5 whys, which is not a real number. It's really just sort of to give you the idea. You keep asking why until you get the answer. Kepner-Trago problem analysis has another approach to that. IBM has a method. They've pioneered a lot of things in software quality. Defect causal analysis. The only reason I'm not a fan of that is because it tends to be very wordy. And I'll get into why I think there's a better way. The idea is to fix the cause and change the process, and then fix the problem using the change process. But how do you preserve the knowledge? And this is where the idea of classification of root causes comes in, looking for patterns and be able to do metrics. And the approach that I happen to like for this is called the Beiser taxonomy. I think I have another slide on this one. So Boris Beiser developed this, and he's retired these days, but he's a well-known author in software testing. He's published, I don't know, about half a dozen books on that. And I talked to Professor Beiser about it because I was extracting this from one of his books, and I wanted his permission. So I tracked him down. I found a couple of email addresses that didn't work and a phone number that did work. And his wife dragged him in from the backyard where he was doing something or other and she said that he would probably give me 15 minutes. Well, 2.5 hours later, when I got off the phone with him, he had explained to me that he developed this method based on the Dewey Decimal System. It's just a number, and it's very extensible, just like the Dewey Decimal System is, and that's the way he designed it. And he told me that if I'd been reading his book from the front instead of from the back, just to find what I wanted, I would have found out that this is the only thing he's ever published that he put in the public domain. And there is a slightly modified version, which has the advantage that I didn't have to type it because it's in a Word document. That was modified by a Danish professor, Otto Winter, who added some extensions to it. And Dr. Beiser recommended Dr. Winter's version of that. And I have seen some papers on the use of this categorization that says you can do it in about 5 minutes per bug. So I think it has a great deal of potential benefit in that you could then take the numerical results, put it in a database, and you could do queries against it to find out where your weaknesses are. The other methods that I've mentioned are orthogonal defect classification and defect causal analysis. So these are the top-level categories that Professor Beiser came up with. You can find that in his software testing techniques book. All right. So software reuse. Now, once again, I've looked a little bit at this in .NET. There's a lot of published libraries that you can get at and reuse in your software that make it easier where you don't have to write things. There's similarly a lot of open source software and libraries available for Java in particular that you can get at. I do recommend that you examine any, in particular, open source software in terms of its quality. Compare it to your own standards. Does it come with unit tests? Obviously, is the licensing appropriate? Can you run it through various static analysis tools and come up with less than horrifying results? Are the complexity numbers and the defect numbers you come up with in line with what you'd like for your own software? I actually have a separate paper on the subject that talks about how to estimate the cost of free software, which one of my colleagues, and it's not original with him, but I like the way he put it, is that free software is like a free puppy. So I'll leave it at that. Now, requirements can also be a key source of defects, and I do cite a study here in Denmark, and this is, again, where people like Otto Winter and another one of his colleagues are involved, where they've done some things with prototype usability testing. And what I mean by that is user interface prototyping, even as simple as just drawing pictures on paper. And this is a very effective way to head off defects at the user interface level, which means at the level of what people are actually going to do with your software. And they got some pretty good results in terms of error reports and usability issues and productivity when they did this, going from one version of a product to another. So here's the one of the keys. And this is a question that I was asked to answer when I first proposed that we impose requirements on the program that I work in to do some of these things like static analysis and automated unit testing. And so what I did was I turned to a tool, software estimation tool. It happens to be the one that's used by the sponsor for the work that I do, which is the Air Force. And so we looked at the cost and benefits of automated unit testing. What I found was that in trying to look for previous work, papers, and that sort of thing, I found organizations either use automated unit testing or they don't, and people don't stop to compare, or if they have done that, they don't want to tell anybody about it. So here's your basic cost problem when you're doing automated unit testing. If you want to test n lines of code, it takes more than n lines of code worth of automated unit test. And so if you put those numbers into your software cost estimation tool, whether it's Kokomo 2 or in this case, what's now known as SEER for software, you're done because you've already doubled your cost. However, I don't believe that that's the case. What you need to do is use a more complete model rather than lines of code to account for the cost-benefit analysis of automated unit testing. So this tool at the time where we did this was known as SEER SEM. It's now known as SEER for software, and it's a product of Galarath Incorporated. And what I did was to bring some credibility into the process. My co-author on the paper that's behind this is Karen McRitchie, who is the Vice President of Development for Galarath. And so she did the cost estimation piece and took into account something which I had not in my original run with this, which was the learning curve. And bottom line up front, it still works. So there are a wide variety of factors that we can take into account here, like staffing, tool use, testing, QA, and we get output of effort and duration and cost and expected defects. So how do we do this? We consider the cost of defects. There's legacy defects to be fixed, there's new defects to be fixed, and there's defects not yet fixed of both kinds. And we modeled the cost using various scenarios using this tool. And we reflected some added and modified code, and we did some comparison with different development techniques, got out schedule and effort, probable undetected defects after the what's called the formal qualification test in my environment, or you could call it an acceptance test. So we're really just looking at the development phase. We're not looking at cost savings or benefits that occur after that. So if you think about that, there's even more savings that come from the maintenance phase of software when you have done this. So here are the examples that we used. The project had three major applications, a couple of vendor-supplied applications, and the criticality was classified as moderate. So we had a baseline with no automated unit test and nominal experience. We introduced automated unit testing, which increases the automated tool use parameter and decreases the environment experience and increases volatility. These are parameters that go into the model. And then we increased automated unit test and added experience, and that increased the tool use parameter and eliminated the experience of volatility changes. So then we got results out of that were estimated schedule months and effort and defect potential and delivered products, sizes, and so on. So this is the detail that Karen McRitchie came up with this. And I'm not going to drill down into all of the numbers here, but what I want to point out is that in all cases, we came out better. That is to say that if you do automated unit testing, and I will throw in my major caveat here, and I will quote directly from a software development plan from a major defense contractor who I won't name and shame. Unit testing, the programmer writes special driver code and steps through it with a debugger. So that's what you have to not do. If you want this model to work, what you have to do is either test-driven development or, worst case, side-by-side writing automated unit tests when you were first tempted to write special driver code and step through it with a debugger. Do that instead. If you have code that you have made work by the traditional manual unit testing mechanism, I will not try to argue that you don't add cost or schedule by writing automated unit tests. You must do it from the beginning. Just like if you're doing static analysis, you have to do it from the beginning. Anybody who has run static analysis tools after even a week of coding will tell you what the outcome of that is. And the outcome of that is that you see thousands and thousands of errors, some of which relate to following spelling conventions and things like that, which you would sort of have liked to have done, but now it's kind of getting to be too late. So don't do that. Use your tools from the beginning if you want to get the benefit of doing it. But in particular, what we'll see here is that when we introduce automated unit testing, we end up getting fewer defects, both initially and then much more so when we add experience. So once you get over the learning curve, you really make out better, but you actually don't do too bad even if you are doing it for the first time. So I would encourage people to start off, bite the bullet, do your best practices to begin with, and you will not regret it. Here's the cost model in terms of schedule months, and once again you'll see that once you learn how to do this, you get better results in terms of cost and schedule as well. And you don't actually pay that big a price even if you're doing the learning curve on that first pass. So it's yes, it's going to cost you a little bit more and take a little bit more time that first time, but once you've overcome that, the payoff is pretty big. So how do we apply some of this in terms of other best practices? And here I like to rely on Capers-Jones. And he and I have had a few go-arounds on the issue, which I'll talk about when I get to his list here, about whether automated unit testing is really that much better than manual unit testing, but you do have to have unit testing. And if you look at Capers' book, Software Engineering Best Practices, he claims that if you combine certain methods, you can achieve cumulative defect removal efficiency levels in excess of 95% and as much as 99%. So here's what they are: inspections, requirements, architecture, design, code, test cases, and of course, static analysis. And then testing defect removal. Now here's where, I think I may have actually convinced him over many conversations that unit testing should mean automated unit testing and not just unit testing. But this is what comes from his initial assessment. Now, like most of the databases that are used, for example, in software estimation tools, Capers' assessment of the effectiveness of different processes comes from his proprietary database of results and techniques. So I will tend to agree with him on this because of his years of experience both at IBM and then as an independent contractor. So what should we do? What does all of this stuff mean? So if you develop software, it means that you should follow general best practices and add them for your technology. Formulate your own guidelines, but stand on the shoulders of giants. Don't make them up from scratch. Don't do what I saw working as a contractor once at a major pharmaceutical research company where they handed me a inch-thick folder of how to write C# code at name of company. Don't do that. Enforce your guidelines through reviews, and if you contract for software development, look at the practices of the competitors and insist on accountability for best practices. In other words, trust but verify. Go ahead and choose who's going to do your work based on who tells you how they do it. But even in that case, drill down and ask for evidence that they actually do things that way. They're not just parroting back what they know you want to hear. If you acquire software for the government, that's a different topic. And I have a whole different presentation on that because there are different things you have to do. If you want, you can't just go and say, I like this contractor better than that contractor. There are formal requirements for how you do that. And I have a separate paper and presentation on that particular topic. So how do you incorporate best practices? You have to both have and require, if you're contracting, a software development plan. What are the processes and practices? What are the tools and techniques? How are you going to manage requirements? What are the reviews and tests that you're going to do, referring back to Capers-Jones' list? How do you do configuration and release management? And are the deliverables well defined? What's your software test plan? Development, QA, and acceptance testing. So, to summarize, I would say that I believe the use of known best practices can improve the quality of software. You can get better results at the same time as lower costs, and if you want those benefits, you have to require best practices. So here I normally will take questions, and I of course have some selected references in this, which will be available in the version that you guys are going to publish. So, questions?
Excellent. Well, thank you so much, Rick. Let's, anybody, you can unmute yourself if you want to ask a question directly. You can put it in the chat. Ori and I can navigate this.
Yeah, I'm not sure I can see the chat.
Okay, that's all right. We don't have any in there at the moment. I've got a question. I'll go ahead and kick us off with one. So I noticed your list of tests there at the end, your inspections and your tests. Would you recommend, do you see those happening like all at the same time, or is that like a series of how you would run your tests?
Well, there are different phases. If you look at that, let me see if I can go back to that.
Yeah, those.
Oh, there we go.
Yeah, specifically that and the next set. Yeah.
Yeah. So, I mean, some of these are obviously things that you do during development. I mean, the subroutine tests and unit tests. So those are developers' tests. Security tests. These are things, it depends on your environment. That you can be talking about active security tests if you're doing web applications, for example. Those are things that you might have penetration tests and that sort of thing that are going on. There are also static analysis tools that are specifically involved with looking for security holes. Now, the free tools do some of that. If you want, kind of serious security testing, some of those tools are fairly expensive. In the environment that I work in, currently it's mandated to use HP Fortify. I think the license for that is in the vicinity of about $30,000. And there are other tools like that, and the prices are sort of in that range also. So it may depend on the potential consequences, you might say, of security failures. But certainly there are commercial tools which are focused on either dynamic or static analysis for security testing. And just like any other kind of, especially static analysis tools, you shouldn't wait until you're done developing before you use them. You might be able to contract out or pay by the drink for the use of those tools, so you might not be using them all the time. Now, if you're using integrated development environments that are able to use static analysis tools either as you write the code or every time you build your code, you should be doing that. For one thing, there is some overlap between the free static analysis tools and the security static analysis tools. If you make sure that you fix everything that the free static analysis tools highlight for you, you will have that much less to deal with when you put a heavy-duty tool against your code. Performance testing, well, there's a saying that you can't, performance like security is one of the things you can't tack on afterwards. You can't fix that very easily afterwards. On the other hand, you need to know what matters. You can't go around optimizing everything, every piece of code that you've written. Some of it will be important and some of it won't be important. So you need to be thinking about that from the beginning. Usability testing. Well, this is something where in some cases it actually pays to have either work directly with the users, as I mentioned earlier, things like prototyping user interfaces, and anybody could do that. There are people who specialize in human factors engineering, and depending on who your audience is going to be and how many people are going to be using your program, it might very well pay to invest in specific human factors engineering to design the way that your system is going to work from the human point of view. System testing is sometimes called integration testing. That's where you actually do your sort of functional testing. And once again, there are tools that you can use to automate that. They tend to be kind of specialized, but depending on how much change and how long a lifetime you're going to have in your software, you either are going to be constantly running manual tests with scripts in order to do this level of testing, or you can automate it. And that's another kind of specialized programming area, actually, scripting of system testing. And then acceptance or beta testing. I mean, this is where you actually go to your prospective user to either get approval or to see how you're doing, if you're talking about beta testing. Or if you're in an Agile environment, this might be something which is actually sort of part of your sprint, that you're doing this all the time, that you have a product owner or user representative looking at your product, since you are in theory at least going to have something that's running at every sprint. It would definitely pay to have eyes on and hands on your product at every step of the way. So I think that's the best thing I can say there.
Awesome. Thank you. Good answer.
Hey, Rick, I have a question as well. This is a very impressive amount of rigor, and we do a lot of this already in our Agile world. But have you actually applied this in Scrum?
Some of it. I'm actually working on a project in Scrum right now, and I have managed to impose some of my views on the way that the team is working. And I'm happy to say that we have reached about 83% code coverage on unit tests for the code that we're writing, for example. And we do run static analysis, and because of the environment in which this is intended, we actually are running the HP Fortify tool and making sure that we have no critical errors that show up on the security scan as well. So, you can do this, and it is being done. And in terms of performance, we have taken a lot of effort to make sure that everything that can run asynchronously is running asynchronously. And that took extra work, but we're still passing our tests. So yeah, you can do this. And actually, I think that it's actually more prevalent, and some of these things are more prevalent among Agile practitioners than they are among waterfall practitioners, in terms of test-driven development is almost taken for granted in at least some Agile practice corners. The development manager who I know who has been doing automated unit testing the longest is a guy who in another life, I sat in the middle of his developers in 1999, and I was doing something that was typical for me at the time, which was developing sort of sample code for other software developers who would be using the underlying software that was being developed by this group. But I was sitting in the middle of the development team, and they had come up with, and I quoted Dana in my article, so he's not anonymous. His name is Dana Coy, but he had come up with something which, and the code was Java, and came up with something that they called a test harness. Now, retrospectively, I sort of went back to Dana and I said, well, that's when JUnit was developed, 1999. He said, yeah, well, they had theirs, we had ours, and they seemed to be sort of equivalent. So we stuck with ours. I said, well, that's great. So what are you doing today? And today was 2008. He said, well, before we released a product, we run 10 or 15,000 automated unit tests. I said, well, can you compare how you did with the product with that approach and with how you did with it without that approach? He said, well, I can't, because we've never done without it and we never will. And that's the sort of thing that I found when I was trying to, that's why we ended up modeling the impact of automated unit testing, because I didn't find anyone who had any serious papers on that comparison. If they did it, they kept it to themselves. That's why I characterize it as sort of haves and have-nots in terms of those sorts of tools. And to my knowledge, and Dana's still there, and after a succession of companies, probably up to about 6 or 7 that that have owned that particular product, still doing it, to my knowledge, because I believe that that's what he thinks, is that we've never done without it and we never will. So that's kind of what you find, is that people who adopt these kinds of tools just sort of intuitively realize the benefit. Now, I had to cost justify it to a lieutenant colonel as to why we would impose some of these techniques on defense contractors that he, as representative of the Air Force to the U.S. government, was going to have to pay for. On the other hand, Dana, as a vice president of engineering, could just say, no, that's the way we're going to do it. You don't want to do it that way, you don't work here. And that's the way it is. So, that's kind of the spectrum of what you see. But yeah, you can do this stuff, and I think it's actually in some ways more suitable to Agile development and more, might say, more simpatico with Agile development techniques than it is with traditional waterfall techniques, where people are off developing the code and they don't know if it works or not, so everybody's in their corner doing their manual testing of stuff. And yes, if you get to the end and you say, oh, by the way, you've got to deliver automated unit tests, or you've got to run and pass static analysis, you'll get people saying, well, here's the list of thousands of errors, and here's the extra cost and schedule for doing the automated unit test. Do you want to pay for it or not? And the answer will be no. So you have to do these things as part of your development or not at all, is what it amounts to. And if you do it as part of your development, I contend that my initial, from the hip, I went to quality college, and I'm going to tell you that if you do it right the first time, you get better results and it costs you less. That if you analyze that, as we did, that you still get that answer. That if you do it right the first time, you get better results and it costs you less. So that's my story, and I'm sticking to it.
I like that story. Awesome. Does anyone else have a question? I'll pause for a second. Anyone else has a question they want to throw out there? Cool. Well, I'll just take the opportunity. I had another one. You opened up with talking about standards, and specifically for developers, which I thought was excellent. It's really, I think, looking at standards and bringing them in for developers to follow is key. I also thought back on my previous project, and while we kind of had standards, not as well as you had defined it, but we kind of had standards for the developers, we really didn't have a good understanding of automation around testing. And so we brought in somebody who at least said they had on their resume, automated testing experience. And then they went to town building automated testing. And so reflecting on those two, are you aware of any standards that we could have found to help us standardize the way that we went about automated testing, like we did the way we went about developing, if that makes sense? Are there any standards you're aware of for new automated tester shows up, hey, we want you to follow these kind of ideas?
Well, not as such. What language were you working in?
That one was, the guy was using Java. He was using Java. Yeah, so I think Selenium. He came in and said, I have this tool, Selenium, and off he went. And we're like, okay, that sounds great. But we didn't have the knowledge or anything in reference material to say we want it kind of to follow these, show us, we didn't have a checklist for him.
Yeah, and I'm not familiar with Selenium, so I don't know whether that it almost sounds like maybe that's a functional test tool.
Yes, it wasn't a web interface. So he was building automated tests around, once we released it, it would go in and it would work through each of the scenarios to make sure that things weren't broken on the web page.
Okay, so that was really a automated functional test. Were you doing automated unit testing?
No.
Okay, so you weren't using JUnit. You weren't using JUnit, for example. Yeah.
No.
So that's a different level, and it's not a bad thing to be doing. That's coming under the heading of what on Capers-Jones' list here, that would be more system test. It's sometimes called functional testing. But what I would say is a best practice in unit testing is one of two things, and one may be better than the other, but I'm not totally convinced. One of them is to do test-driven development, where the developer writes tests, or you could have somebody else write them, but then you're really more into pair programming. You need somebody who's not, sort of a traditional QA tester who's used to following scripts and typing things and that sort of thing. Either the same person who writes the code, or some people like to prefer somebody else, so that you don't sort of get yourself wrapped around the axle, with the same assumptions in the unit test as you have in the code under test. But nevertheless, either writing tests that fail to meet the requirements, or as you're writing the code, stop and write the test before you fire up the debugger. I think either one actually works as a practical point of view. But then, from the point of view of the sort of the organization, or the work group that's doing the development, what you can do, continuous integration is obviously a good practice to be following. And one of the things that you can do is that you can require your unit tests to be checked in along with the code, and you can refuse to check in code that does not include unit tests that have the required code coverage. You can refuse to check in code that doesn't pass stack analysis with whatever tool you're using. So that's a pretty good discipline that you can follow. You can have your build machine run the unit tests, flag anybody whose test fails, and not merge it into the main branch if you're using branching. There are some people who don't like to use branching in their source control and want everybody to work off the main branch. But all the same, you almost need to enforce the discipline. Basically, programmers in general don't like to be told what to do or how to do it. So you need to sort of accommodate that in a way that says, yeah, you have to do it this way if you're going to be part of the project. I know that if you're developing code at Microsoft, for example, you don't have a choice about writing automated unit tests. It's just the way it is. If you want to contribute to certain open source projects, you have to follow that discipline as well. I actually was just meeting with some of the key players at Microsoft's open source project for Microsoft.net, and anybody can contribute, but it goes through their team before it gets merged in, and it has to conform to the practices that they require. So they're getting lots of benefit from people contributing code that in some cases, because it's code that they're particularly interested in, that may perform much better than the original. But it doesn't get merged in until it also passes the other requirements in terms of quality and and even following the same coding standards and so on. Because you have to, it's beneficial to even follow the requirements that your static analysis tool may lay on you as far as how to spell things, because it's easier to maintain code that looks the same. You don't necessarily want to have your programmers all expressing their individuality in the way that they name and spell things. You want to be able to pick up code from one person and give it to another one. In the environment in which I work, you want to be able to pick up code from one company and give it to another one. So it's even more important that you do that. So awesome. if you want your code to live and not depend on, somebody put it at the conference that I was just at, how do you evaluate your code in terms of how many people have to get hit by a bus before you fail? If the number is 1, then you're doing something wrong.
Yep.
And a lot of Agile development teams like the idea that you switch people off on different parts of the code on a regular basis. So if you're going to do that, then you really do need to have standards and do things the same way so that you don't have enormous learning curves between people. You don't have what I call the programmer's gag reflex when they pick up somebody else's code. Or your first reaction is, this is all wrong. Is it okay if I just rip it all up and start over? Well, you can't really afford to do that. Yeah. So you have to kind of prevent that programmer's gag reflex. And the best way to do that is to have everybody's code look more or less the same.
Yep. I've heard that one before from a developer arriving new on the project. Hey, we've got about 3 minutes here, but I have one more question for you from the audience that I think would be a good one to wrap up on.
Okay.
Which is, what suggestions or advice would you give someone who has a large backlog that needs to be automated?
What do you mean by that?
my assumption is it's a lot of items, so they're behind in the we've built this, we've built that, we've built this, we've built that, and now all of a sudden, okay, let's go put automation on it. Well, there's a lot of things that need to have automation applied. So a low code coverage percentage. Where do you start eating that elephant?
Well, here's the problem. As I said before, the model that I came up with to justify why it doesn't cost any more to do that is based on you're having automated unit tests that you do in parallel with the coding. If you really want automated unit tests, but you've got all this code already written, if that's what you mean by the backlog, if you don't mean stuff that hasn't been written yet, you're in trouble. It's going to cost you more. It's going to cost you those N plus 25% or 50% lines of code to write that stuff. And the only way you're going to be able to justify that is a way that I couldn't in my environment, which is by the maintenance cost savings that will accrue to you later. If what you're talking about is that you have a sprint backlog of stuff that hasn't been developed yet, and your team has not yet learned how to use these tools, you have a decision to make, which is, I think, it will benefit you if you bite the bullet, especially if you have a lot of stuff that you haven't done yet, to overcome that learning curve and learn to use those tools, because you will be happy about it later, especially if you're under schedule pressure and you have to refactor things or rewrite things. If you don't have automated unit tests and you get into a lot of refactoring or fixing things, you are likely to be introducing defects every time you make a change, you run the risk of or fix something in particular. Whenever you fix things, you run the risk of introducing other defects. And automated unit tests used as regression tests will help prevent that. They won't, it's not a magic bullet. It won't absolutely prevent you from ever breaking one thing when you fix something else, but it will give you a much higher degree of confidence that you haven't. So I think I've tried to address the ambiguity in that question.
Yeah, excellent. Well, thank you very much, Rick. I want to say on behalf of myself and Lori and Jeff and Heidi, who weren't able to be here, thank you so much for joining us and for sharing your thoughts. And we really do appreciate you taking the time to share this with us. It's been very, very helpful.
You're more than welcome.
Yeah, excellent. All right, and for everybody else, I'll just say that we will have we'll be updating coachingagilejourneys.com with our next speaker, and you can head there for information on it and to register there for our next speaker and to keep up to date with the ones that we're showing. If you're looking for the recording or the deck that was shared today by Rick, we'll have those up on the blog in a few days, maybe a week or so. It depends on how long our turnaround time is. But you can go there for any resources and any other information you need to connect with us. Thank you, everybody. Have a great rest of your day. Bye-bye for now.
Bye.
Bye, all.